What if I told you that the red of a sunset, the blue of the ocean, and the green of the forests don't actually exist? That the entire spectrum of colors you see every day is, in some ways, an illusion created by your brain. This might sound like science fiction, but it's actually a fascinating reality that sits at the intersection of physics, biology, and philosophy. Let's start with a simple question. What exactly is color? When we look at a red apple, we believe we're seeing an inherent property of that apple. But the truth is that redness isn't a property of the apple at all. It's a story your brain is telling you, an interpretation of something far more fundamental happening in the physical world. Let's start with what's actually happening when we see color. Everything begins with light, pure white light from the sun or artificial sources. This light is made up of electromagnetic waves traveling through space at different wavelengths. When these waves hit objects around us, some wavelengths get absorbed, while others bounce off and eventually reach our eyes. Take our red apple. Its surface is composed of molecules that absorb most wavelengths of light, but reflect the ones we perceive as red. But here's the crucial point. There's nothing inherently red about these wavelengths. They're just energy vibrating at roughly 480 trillion times per second. The sensation of redness only emerges when our visual system processes this information. The light enters our eyes and hits specialized cells in our retina called cones. Humans typically have 3 types of cones, each responding to different wavelength ranges. We call these short, medium, and long wavelength cones. This 3-cone system is what gives us our trichromatic vision, but it's just one of many possible ways to see the world. Consider the mantis shrimp, which has 16 different types of color receptors, or dogs, which only have 2 types of cones. These creatures live in the same physical world we do, but their experience of color is radically different from ours. The mantis shrimp might see colors we can't even imagine, while dogs see a more limited palette, yet neither version is more real than the other. But the real magic happens in our brain. When those cone cells detect light, they send electrical signals to the visual cortex. Here, millions of neurons work together to construct our experience of color. The brain doesn't just passively receive information about wavelengths, it actively creates the sensation of color as part of its model of the world. This explains some fascinating phenomena, like why we can see colors in our dreams, or why people with synesthesia might experience colors when they hear music. The brain is creating these color experiences without any actual light waves involved. Even more intriguing is the question of color constancy. Have you ever noticed how a white piece of paper still looks white under different lighting conditions? Whether you're in fluorescent office lighting or warm sunset light, your brain adjusts its interpretation to maintain consistent color perception. This isn't just a passive process, it's your brain actively working to create a stable, useful model of the world. The complexity of color perception becomes even more apparent when we look at edge cases. Consider the condition of achromatopsia, where people can't see colors at all, or tetrachromacy, a rare condition where some people have 4 types of cone cells instead of 3, potentially allowing them to see millions more colors than the average person. Then there's the fascinating world of impossible colors. Try to imagine a reddish green or a yellowish blue. You can't, because our brain's color processing system makes these combinations impossible to experience, even though they could theoretically exist as wavelength combinations. Cultural and linguistic factors add another layer to this puzzle. Different languages carve up the color spectrum in different ways. The Himba people of Namibia, for instance, categorize colors very differently from English speakers, and research suggests this affects how they perceive colors. This raises questions about the relationship between language, thought, and perception. Think about your favorite color for a moment. Maybe it's the deep blue of a twilight sky or the warm orange of a sunset. Now consider this question. How do you know that your experience of that color is the same as anyone else's. Even if we both point to the same wavelength of light and call it blue, could your internal experience of that color be completely different from mine? This is the famous philosophical problem of inverted qualia, first proposed by John Locke in the 17th century. Imagine if someone's color perception was systematically inverted from birth. They see blue where you see red, and red where you see blue. Since they learned the same color words as everyone else, pointing to the same objects, we might never know their internal experience was different. They would still stop at red traffic lights and go at green ones, still describe the sky as blue and roses as red. This thought experiment reveals something about consciousness and subjective experience. Even if we understand every neural pathway involved in color perception, we still can't bridge what philosophers call the explanatory gap, the divide between objective descriptions of brain processes and subjective conscious experiences. Consider the philosophical thought experiment of Mary the color scientist. Mary knows everything there is to know about the physics and neuroscience of color perception, but she's spent her entire life in a black and white room. When she finally sees the color red for the first time, does she learn something new? This question, posed by philosopher Frank Jackson, highlights the difference between knowing about something and experiencing it directly. This leads us to an even more fundamental question. Is your red the same as my red? We might both agree that fire trucks are red, but the subjective experience, what philosophers call qualia, might be entirely different. We have no way to directly compare our internal experiences of color. This is part of what makes consciousness such a hard problem for science and philosophy, but perhaps we're looking at this the wrong way. Some philosophers argue that colors aren't properties of objects or even of our minds, but rather relationships between perceivers and the world. This view, known as relationalism, suggests that colors are more like dance moves than fixed properties. They exist in the interaction between observer and observed. This brings us to an interesting parallel with quantum mechanics. Just as the act of observation affects quantum systems, our perception of color isn't passive reception, but active participation. Colors emerge from the dialogue between our consciousness and the world around us. Think about how this changes our understanding of reality itself. We often assume there's a clear line between the real physical world and our subjective experience of it. But color perception shows us that this line is far blurrier than we might think. Our experience of reality is always mediated through our consciousness, shaped by our sensory systems, our brains, our languages, and our cultures. This has implications for how we think about knowledge and truth. If something as seemingly simple as color turns out to be so complex and observer-dependent, what about our other experiences of reality? What else might we be taking for granted as objective that is actually a construction of our consciousness yet? This doesn't mean we should embrace radical skepticism or conclude that nothing is real. Instead, it invites us to adopt a more nuanced understanding of reality, one that acknowledges both the physical world and our role in perceiving and interpreting it. Colors might not exist in the way we naively imagine them to, as properties painted onto the surface of objects, but they're real in a different and perhaps more interesting way, as bridges between the physical world and conscious experience, as tools our brains have evolved to help us navigate reality, and as shared experiences that connect us to other conscious beings. This understanding of color offers us a new way to think about consciousness itself. Every time you see a color, you're participating in a miracle of consciousness, the transformation of meaningless wavelengths of light into rich, meaningful experience. As we conclude our exploration of color, we're left with a deeper appreciation for both the complexity of perception and the mystery of consciousness. The next time you watch a sunset or admire a rainbow, remember that you're not just observing colors, you're participating in their creation, engaging in an ancient dance between mind and world that has fascinated philosophers and scientists for centuries. Share this video with someone who loves questioning reality. Subscribe to our channel and hit the notification bell to join us as we explore other aspects of human consciousness, from the nature of time to the mystery of self-awareness.